Hello, and welcome back to the RAD Mobile Development Kickstart series from Developer Direct at Embarcadero. My name is Al Manarino, and I'm one of the Embarcadero software consultants. Also joining us on this lesson is David I., Stephen Ball, and Jim McKeith. We'll be taking you through this lesson 4 on accessing local storage. We will learn about file handling using the IOUtils and sysutils units, and we will explore different types of file storage, like using INI files and T client datasets. And we will learn about the two embedded databases you can use with iOS devices, which are Embarcadero's Interbase and SQL Lite. And we'll also learn about Embarcadero's new multi-device data access library called FireDAC to enable native high-speed direct database access from RAD Studio, Delphie, and or C++ Builder. Today's lesson is the fourth in our series. If you are watching this lesson 4 on a replay, then please, if you have not done so already, have a look at the previous 3 lessons and follow your way through the series to pick up the best of everything. If you are joining us live, then please use Twitter and the hashtag EMBTDD, and also follow us at Embarcadero Developer Direct at EMBTD Direct. If you have any questions during this week, then please email us at developerdirect.online@embarcadero.com. And even if you are watching this as a replay in the future, please also use the same email to ask for any resources you cannot find or anything you have seen through the series that you would just like some further guidance, and we'll point you to the relevant resources. So let's get into the core of this lesson on accessing local storage and the samples included with Delphie XE4. For this lesson 4, we'll get into the details on how to use IOUtils and sysutils for file handling. We'll see how we can use sysutils.getHomePath method to get the file path on an iOS device. And we'll also be using the path_delim constant, and that's recommended as path_delim specifically uses the path delimiter of the target platform, instead of having to hard code delimiters such as / or the /. And we'll also see how to use if-def conditionals for the iOS device for file handling. We'll explore these 3 different types of file storage on the iOS devices. We'll see how to access and use INI files to read data from INI files. For client datasets, we'll see how to create save to file and load from file. We'll see how to add files using project deployment options. We'll see how to embed Embarcadero's Interbase database or SQL Lite database into an iOS device. And lastly, we'll see how to use Embarcadero's new multi-device data access library called FireDAC to enable native high-speed direct database access from RAD Studio, Delphie, and or C++ Builder. And FireDAC also gives us great performance when using multiple connections. Many of the sample apps we'll be using during this lesson are available on SourceForge from this SVN link on this slide. Also, if you have installed RAD Studio XE4 or Delphie XE4, then you will have these sample apps already installed in your Documents folder on your local machine. And typically they're installed under Users, Public, Documents, RAD Studio 11 Samples. So we do use SVN for the storage of these samples. So if you want to update your local versions, then you can install a local SVN client such as Tortoise SVN, and then right-click and update, and that will pull down any additional updates and changes or enhancements to the samples. And if any additional samples have been published since your installation, then you'll get them also from the SVN update. Comparing Interbase IB Lite, Interbase to Go, and the Interbase Server Edition is defined in this Interbase IB Lite and Interbase to Go Quick Start document. It defines that the Interbase to Go edition has two different platforms, To Go and IB Lite. Developers targeting database application deployment to an iOS device can deploy either with a cost option with a To Go license or a no-cost option using the Lite edition license. To Go and IB Lite have the same development model. Both are embedded applications using the To Go library. And lastly, all of the FireDAC documentation for the FireDAC Universal Data Access components for developing cross-platform database apps on Delphie, C++ Builder, and Free Pascal is at this link. File paths on iOS devices is different than file paths on Windows. For iOS, we need to explicitly define where our files are located on the iOS device. Also on iOS devices, upper and lowercase file names do make a difference. So to help us put and find files on our iOS devices, we are going to use system.ioutils.tpath.getHomePath. GetHomePath returns the home path of the application's writable scratch directory or storage. On iOS, it points to the device-specific location of the sandbox for the application. The iOS home location is individually defined for each application instance and for each iOS device. Now I have a note here that system.sysutils.getHomePath has the same functionality, but it's not recommended for any new or cross-platform development. So in our case, for iOS development, it's recommended that you use the more platform agnostic implementation, and that's to use tpath.getHomePath. In addition to using this tpath.getHomePath to give us the actual home location of an iOS app, we're also going to use this constant sysutils.pathDelim, which specifically uses the path delimiter of the target platform instead of hard-coded delimiters such as a / or a /. So if we look at this example where we dropped a SQL connection onto our form to tell iOS where this file actually exists, I'm using an if-def conditional, and I have its tpath.getHomePath plus its path delimiter plus documents plus path delimiter plus the name of the file I want to store on my iOS device. So for an iOS device, the tpath.getHomePath, that will give us the remote path on an iOS device of startup. So we have startup / documents / and then the final name of the file. Let me now show you iOS utils and sysutils in a quick demonstration. I'm in Rad Studio XE4 and I'm using Delphie XE4. I'm going to create a new FireMonkey mobile application. I'll pick a blank application. Now I want this to be a database app, so I'm going to go over to my Data Explorer tab and I'm going to drop one of my DB Express connections onto my form, and by doing so it automatically creates a T-SQL connection for me. In my app, I want to store my Interbase dbdemos.gdb file on the iOS device under the startup / documents directory. So I'm going to use the T-SQL connection before connect event to set the path to the database. So to connect to the database at runtime on the iOS device, that is, an if-def iOS is used. Next, I want to set the database value of my T-SQL connection equal to the path of my Interbase file on my iOS device. So my T-SQL connection is called dbdemos. And I want to get its params. And I want to set its value of the database. Now here's where I can use my iOS utils and sysutils for the path. So I want to use my tpath, and I want to get the home path, and then I also want to use the constant path delimiter, and I want to put it into the documents folder. Add another path delimiter, and then finally the name of my Interbase file, which is dbdemos.gdb. So that does that. At this point, let me save this project. I'll click Save All. I'll put it into a new folder. I'll keep it as Unit 1, and my project name, which will become my app name, let me call my developer direct tpath app. Now with this path, this file dbdemos.gdb, it's going to be stored and located at startup/documents. So let me just put a comment here to remind us about that. So my tpath home path for the iOS device, home path would be startup, and then I have path delimiter for /documents, path delimiter / and then the final name of my file, dbdemos.gdb. Now, of course, you can use any directory which is available to your app on the device. But by using this documents folder, it has the advantage that everything in here will be included in the iOS device backup process. So this is true for local backups if you're using iTunes or iCloud backups. So you could, for example, use a /temp folder, but by doing so, or any other folder other than documents, that folder would not get backed up. So just to kind of repeat here, this tpath get home path, so that function gives us the actual home location of an iOS app, and then using the path delim constant, which is recommended because this path delim specifically uses the path delimiter of the target platform instead of having to hard code delimiters such as the / or the /. For this next part, and I'll go into more details when we get into the embedded database section of this lesson, but for now I'll tell you, since we're deploying an embedded database, Interbase database to our iOS device, before running this app on the iOS simulator or the iOS device, we're going to have to add some additional items to the deployment manager. And we can get to the deployment manager from Project Deployment. So here we have the deployment manager, and we see in the deployment manager it lists all the files that are going to get bundled and deployed with our app onto the device. So it is important to note that we have a local file path and a local name on our development machine, and we have a remote path and a remote name. So since this is an Interbase database file, I'm going to need to add the Interbase client files, and I'm also going to add my free Interbase IB Lite license file, and I do that using featured files. So under Interbase, to my iOS simulator and to my iOS device, I want to include my IB Lite registration file, to both my iOS simulator and my iOS device. And by doing so, you see it updates those files in my deployment manager with its correct local path, local name, and the remote path of where it's going to put those files. And if you see on the remote path, it also puts them under startup/documents. Now next and lastly, I need to add my actual Interbase dbdemos.gdb file to this deployment manager. So for that, I'll use Add Files. I'll select the location of my file, dbdemos.gdb. So here's my local file name and its local path name. But on my iOS device, I want its remote path name to match the path we put in our application. So in my case, it's startup/documents. And save all. Now, an important point to note here is file names on iOS devices are case sensitive. So here, my file is called dbdemos.gdb, all in lowercase. And in my app, the file is also called dbdemos.gdb, all in lowercase also. So, lastly, I want to write a procedure that's going to let me check the paths on the iOS device just to make sure that my dbdemos.gdb file actually gets placed where I think it should be placed. So to do that, on my device, I'm going to drop a button, and I'll call this button my check paths. And for the button one click event, I want to make sure that this get home path documents, dbdemos.gdb really exists. I already have code to do this, so I'm going to reuse it here and then I'll walk you through. So what this code does is I have two variables, test and path. So my path is set to my tpath.getHome/documents / and then my test variable is my path variable with dbdemos.gdb. So that's what I'm looking for. So what I want to do is first make sure I got the path set correct, and then on my iOS device I want to test to make sure that dbdemos.gdb is found in this path. And then if it does find the path, and then I want to iterate through that directory, and I want to display all the files it finds there. So this is a very good procedure I use just to make sure the files I think are being put onto my iOS device are in the place I expect them to be. So at this point I'm going to save all, and I'm going to run this application on my iOS device. So I'm going to set my target platform to be my iOS device. And then I'm going to run the application. It will build it here on Windows, and it will deploy it to my iOS device, and it'll run on my iOS device. And then we'll click on our check path button, and we'll make sure that our dbdemos.gdb file got deployed and got put in the correct location. Okay, the app got deployed to my iOS device. Let me switch over to my Mac, and let me turn on my AirPlay mirroring so you can see my iPad. So here's my iPad with our app running. I'm going to click on Check Paths. So it tells me my path. So as you recall, we set it to startup/documents, but on the actual iOS device, my iPad, this is the actual physical location of where it's putting it, /private/var and the rest of it. Then we have documents at the end. I'll click OK. So it does the check to see if it finds dbdemos.gdb in that location, and it does, so that's great. And now, since it found the path, it's going to iterate through that directory path and tell me all the files that are in there. So it does find my dbdemos.gdb file in there. So that's a great check, just to make sure. So that was a quick overview on file handling on iOS devices using IOutils and sysutils. The next topic we will cover is INI files. For this, I'm going to turn this lesson over to Stephen, who will show us how to access and use INI files on iOS and how to list the files on the device.
Thanks, Al. So yeah, let's have a look into INI files. Now, INI files are great for being able to just save some configuration information down and load it back up. INI files work with name-value pairs, and you can have multiple sections within INI files. And we'll go and explore the INI file in a moment, but here's just an example of some INI file code. And we'll go and explore this today, but you can go ahead and download this from the links on the streaming site, or if you just go to cc.embarcadero.com/item/29501. CC is Code Central, and there's lots of different code examples up on Code Central. It's a great place to get to know as part of your experience around the Embarcadero Developer Network. So, using what we've already learned about getting the home path and the path delimiter, we're going to be storing our INI file in the Documents folder so it can be backed up, but also so it doesn't get removed. If it's in the library or the library cache folder, then there's the chance that if they clear the cache on the device, it's going to be lost, it's going to be taken away. And you should only put stuff in the Documents directory if you need to persist it. If there's temporary things that you're downloading, like videos or articles, or the latest list of properties from a search or something, then you put those, if you need to store them onto disk, into the library cache folder. And otherwise, if it's something you want to persist and you cannot recreate it through the application, then you can put it into the Documents folder. That's the kind of loose rules around it. So we're going to create this because it's special information and store it away into the Documents folder, and we're going to call it myd for developerdirect.ini. Okay, so the two events that I've got here, we've got two button clicks. The first one is going to read from the INI file. So we create a tINI file object with the file path. So it's going to go read this document. And what this will actually do is, if the file doesn't exist, it will go create it. So it exists. We are then able to read the INI file. So we're able to read the string, and we're reading a string from a section called section, and we're reading the value called ID. Now, if that value exists, we'll get the value back. If it doesn't exist, then you get the default value that you pass in. So if you wanted to have, for example, a URL for a website, then you could put a default in there, and then you'd still allow people to override it and move to a local website or a server IP address or something. But you can have a default if you need it. Now the second one, here we're creating the INI file, and then we're going to free it afterwards using the try finally block. We're going to read, so we're going to write a string into the INI file. We're going to write to the area called section, and we're going to write the ID value, and we're going to pass in the value from the screen. Okay, so let's go and have a look at that in code and explore a few other bits around the INI file. So here's the example that I've just told you about on Code Central. There's a label at the top here which we're going to populate on startup to tell us the application's path on the iOS device. And then here, this is our edit value, which is where we're going to put the value into and save it away from. So we've got the load, which is going to read it, the save that's going to save, and then on the delete button here, We've got a method to just check if the file exists, and if it does exist, we're then going to try and delete it. And if it deletes, then we're going to show deleted. If not, we're not going to show. We're going to show not deleted. If the file doesn't exist, then nothing's going to happen when you click the button. Okay, so let's see what else we've got under here. Here's the kind of just the start up, the form create. We've got an event to set the ini file into the text1 text. So let's go and have a look at that to start. So here's our application, and we can see here this is the path, the actual path on the device. So let's go ahead and put a value in here. So let's put in hello world, and let's just save that down. Now if I clear the edit, and now let's use the load button, we can see it's now reading that section from the ini file and loading it in, which is great. So let's just go clear that, and now let's delete the file, and we can see that's come up as deleted. Now if we choose load now, then obviously nothing's going to appear because we've not got the file there. We've actually deleted the ini file. Okay, so let's go ahead and put something back in again. So we can put here Delphie rocks. Let's just save that down. So we've now got our ini file there. It's loading our text in, which is great. Now there's one other thing that I've done in this sample that I just want to explore quickly, and that's the file listing tab here. So here we've got a list box, and if we just refresh this, we can see here it's got the ini file. In fact, I've got a couple of ini files. I've been playing around with different file names on here. So we can see here we've got the myd ini file that's been created, and if we go back here and actually let's just delete, and that's now been deleted, and if we refresh our list we can see that's disappeared. But we can also see here the other files, and in fact let's just change the device here to be an iPad. Let's open that up. And you have to excuse my resolution's a little bit big, so let's just try rotating this left. There we are. We can see everything now. So we can also see here we've got other folders and files that we can see are part of our application. And indeed, before I was playing around, I actually had the loading to the library. Now if I go and clear the cache, then that's obviously under threat for that being one that's going to disappear. So best place, if you need to keep hold of it, pop it into the documents folder. So how do we get this tab working? Well, I'm just going to expand this section of code. You can see we get these little plus minus signs here in the IDE. So let's just expand this button list click. And it's quite a simple method here, just using a little bit of recursion. Let's just move that out of the way. So when we click, we're building up the search path. So we're getting the home path as our starting point. And then because we're going to be running a lot of updates to the list box, we call this begin update method. And that means basically wait till I've finished telling you all the changes before you go start drawing everything. Otherwise you're going to be quite slow. So we then clear the list box, and then we call this little inline method here called doListFile, and we pass in the path that we're at. So that then uses find first to go and locate any file. So you can explore the find first in sysutils. There's loads of examples, way back when people are using find first and find next and so on. So you can loop through all the files that it finds. We're able to check the search result attributes to find out if it's a directory. And as long as it's not the dot or the dot dot directory, then we're saying, okay, go list the files in this directory as well. And at that point, we're saying, take this search path plus the name of the directory and the path delimiter and go load that one. So it's going to load them in order. If it's not a directory, then the else is going to fire here, and we're getting the path from the actual root. We're actually building up the full root, sorry, we're getting the file path from the root by copying the full file name, including the search path, and then copying it from the position that the home path ends. So we're saying give us that point where it ends to, and then copying the rest of the length of the file name in. So that then gives us everything excluding the root bit. So if we come back here, we can see that this is starting documents my ini file, whereas the documents bit starts here. So all this bit at the front, which is the special folder that we're sandboxed inside, we're saying we don't want to list that bit because it's always going to be the same. So that's what we're doing with the copy there. So that's getting hold of and bringing back and using an ini file. So let's just explore some of the other stuff that we can do with ini files. Let's just collapse this back up. Now I'm going to just come in here and let's just type ini dot, and then by doing that we can see the documentation insight coming up. We can delete a key, we can delete a specific key from an ini file. We can erase a section. So this is the section name, and these are the name and value pairs. So we can erase a section. We can get a list of strings. We can read a section, so we can actually say give us a list of all the names of the values and their pairs that are with names and values within a section. We use t-strings there, so a t-string list would be a great object to pass through. We can read sections, and that will give us a list of all the different sections, the names of all the different sections within the ini file, so we can then iterate through them. We can read section values, so we can go get a list of all the values from a specific section, and so on. You can read a string, you can read an integer, and if it's not an integer, you can set the default to return back. And then obviously writing strings, writing integers, reading Boolean values and writing Boolean values. You can read a binary stream, even you can date times and so on. Just be careful with the date times if they're going to be used in different date time format encoding. You may find you want to just store them as strings in a format that you're always going to check for and convert them back. Or the other option is to store them as floating values, because a date time is a float value, and then you can always save that down and back up no matter what the date time that you're working on. So there's a whole host of different things in here on the ini files that you can go and work through, and it's the same thing, just ini dot and then read or write the value type that you're looking for and then passing the values through. Okay, so Al, what do you think of ini files?
Thanks, Stephen, for that great, excellent overview on ini files. One question I'm asked with Delphi for iOS is, what's the easiest way to store some very small data on an iOS device for quick reading and writing? I just need to store some simple app settings. So a great answer is to use the ini file on the iOS device.
Okay, so ini files are one way to do it, but another way you can use is client data sets, and these give different options and also advanced filtering and stuff that you can do with data sets, and are a great way to save some values to and from disk. So I love ini files. I've been using them for years, and they're very, very useful and flexible for small amounts of data. But if you want to put a bit more data in, or have more complexity around the data, maybe have records and be able to search and locate things very easily, then the functionality that client datasets brings are straight out the box is fantastic and very useful for storing values in a similar way. So I think, David, how about a little bit more about client datasets?
If you need a lightweight storage system in your mobile applications for Delphi exe4, you can use client datasets. Client datasets are specialized datasets that hold the data in memory, but you can also save the data into a local XML file or a local CDS file. We call it the MyBase database. Let's take a look at how easy it is to use client dataset in a mobile application. So we'll say File, New, FireMonkey mobile application. Let's just do a blank, simple application. And we'll put down a client dataset component. This client dataset component, we can do several things with it. We can right mouse click and, for example, add fields. We can also assign a local table to the client dataset. And we can also load from a MyBase table. And MyBase tables are either the XML format or this client dataset format. So let's do a client dataset. And we'll load in so we can see some data live at design time. We can also then load and save client datasets at runtime in our code. exe4 comes with some sample databases. So we go over to our user public documents, Rad Studio 11, go to the data section, and you'll see a set of XML files and the equivalent client dataset files. Let's just choose the customer client dataset file. Now we've got some data in there. We can right mouse click, bring up the fields editor, and look at all the fields that are available. We've got a customer number, a company, a city, a state, zip, country, a phone number, a tax rate, a last invoice, date, a T-date time field. You can also add new fields, and there are lots of different data types that you can have inside of your client dataset, including memos, graphics, bytes, booleans, and so on. You can also do calculated fields, and you can even do aggregations like sum, min, and max, and so on. Let's add a toolbar. Up here we can put labels and other things and controls, and we'll add a couple speed buttons. So for example, we'll put a speed button in the toolbar, and we'll give that speed button a name, and we'll call it our Open Client Dataset speed button. And then we can do a click event handler for it. Here we'll just say client dataset 1.load from file. And since we're going to be on a mobile device when we load this file, first thing we'll do is we need to get the home path and also the path delimiter, because those can be different on different platforms. Then we'll add documents, and that's the subfolder in my startup folder where I'm going to find files, for example, that I want to be backed up when I run iTunes or I do backup to the cloud. Anything that's in the documents and subdirectories beyond that will show up there. And then we'll add a path delim. Then we're going to call that file, we said that was our customer CDS file. And then we'll end the load from file. So when we click on that Open CDS button, we'll load the file, and then we'll activate the client dataset by setting its active property to true. We'll put another button on the toolbar, and so we'll give this a different style, and we'll call this our close CDS button. Let's go back, and while we're doing this, set the Open CDS button dot enabled to false, because it'll already be open, and we'll take the close CDS button and we'll set its enabled property to equal true, so we know that that's how we can close it. And let's do the click event handler for the close CDS button, and here we'll just say client dataset active false, and we'll take these two button enabled commands and reverse them. And then inside of this client area we can put a couple of tab items. So let's put a tab control. We'll align that to the remainder of the client area, and we can add tab items, 2 items. Let's take the first one, and this will be our customer list tab item, and the second one will be our customer detail tab item. And we'll put those tabs at the bottom, and we'll give them style treatments as well. So for the customer list tab item, we'll give it a list of customers, and for the customer detail, let's give it a style for a specific customer. And change this text to customers, and this is going to be customer detail. And then for the customer list tab item, we'll add a list view. We'll align this to the client area so that when we're on the customer, we'll have the customer list. So let's bring up the live binding wizard. We're going to link the list view with the client dataset's company name. And it creates our bind source DB and a bindings list we can just place somewhere on the form. And we can bring up the live binding designer and associate the company name with the item text that's going to show up in the list view. And now we've got our customers in a list. So let's make sure that we're inactive. We can go under project deployment, and most of what we need is already available as deployment files. We need to do a couple more things. One is to add feature files. Client dataset uses the Midas library to provide the ability to load files, save files, make changes to files in the client dataset. So we'll add that. We don't need any other database drivers or other information because we're just using the client dataset's ability to save and load data and edit data in itself. And we need to add one other file, which is that client dataset file, which is of customer information. And that was over here again in users public documents, Red Studio 11, samples, data, and it was the customer CDS file that we wanted to use. So we'll choose customer CDS. And for customer CDS, we want to put it into our startup, which is capital S, capital U, documents folder, which is capital D. So let's just try running this on the simulator. We have over here Target Platform Simulator. So we'll compile, link it. It will send it over to our Macintosh side. We've got our application. So now if I click on the first part, we've got client dataset data. If I close it, then we're back to where we were. Open it and close it. And again, everything is happening locally on our iOS device or our iOS simulator. Look at the form, choose the second tab item, which is our customer detail item. And let's go and activate in the toolbar the customer. So here we can just put a few controls. Let's just put a couple edit controls. And so here's an edit box, and we'll bind this with the live binding wizard via the bind source to the company information. Let's bring up the designer and layout. We've got all these bound controls now, so this is nice. We've got our edits, our labels. If you remember back in the client data set, we have date and tax rate and such. So let's take that tax rate and let's add a new field as a calculated field. And we're going to call this the something called like whole tax, for example. And we'll make this a float. So we've added a calculated field. There's an event on the client data set called on calc fields. And in here we can do all of the field calculations that we need. On client data set, there's a property called auto calc fields. That's set to true. You can also calculate fields on demand. In AutoCalc fields, the calculations take place when a data set is opened, when it enters edit mode, when it's retrieved from a database. In this case, we're just doing local, or you move from one visual component to another. It'll check to see if it has to calculate it. And then I added another event handler on the list view for item click. and that gives me the item that was selected. And so I use the item selected to find the right row in the client data set, so that when I move to the client detail item, when I move to the customer detail page, I'll see the right data for that customer. So I do that by taking the index for the item that was selected from the list view when I click on it and move the cursor in the client data set. I also call this reset needed to make sure that the live binding engine is bound to the right element in the client data set for the display through the binding system. And then I activate the tab, which is the customer detailed tab item. Now we can add to this editing customer information, saving it back. Just as I did load from file, I could also add a save to file to save the data back out to the client data set. Let's go and run our application. We'll open up the data. And when we're on a specific customer, we'll see its name, the last invoice date, the phone number, and this whole tax rate, which would have been 8.5%, but we would like to look at it in the whole numbers just to show a calculated field. We can go to a different customer, and so on. So client dataset gives you a lot more capability for doing local data access inside of the client dataset itself in memory. You can set a filter expression, for example, a country equal a certain value, just show me the rows or customers in that country. We can turn on the filtered property for that expression. We can also set ranges, so we can set a range, for example, of customer numbers or a range of zip codes. There are methods for setting the range. And you can also do aggregation, sum, minimize, maximize, and you've already seen calculated fields. So client dataset is a great, lightweight, in-memory dataset that can handle and process XML and these binary client dataset file formats. And you can make changes in memory and save them back to the binary MyBase format or to the XML format. And you can also load them at design time and at runtime in your own code. That's just a quick look at what you can do with client dataset.
Thanks, David, for showing us T client dataset. Now we'll turn the lesson back over to Stephen to show us database connectivity from iOS, either using Interbase or SQL Lite. And Stephen will also show us FireDAC, which is Embarcadero's new multi-device native data access library.
Yeah, thanks. It's great that Delphie is so enterprise ready. We're going to be exploring through in lesson 6 and lesson 5, in lesson 5 web services and lesson 6 data snap, some of the great middleware architecture that we have that allows us to connect into services remotely. But one of the great ways is using FireDAC to access to your database if it's on your server or even if it's on the actual device. So we use the same database components to access a local database as we would a remote one. So we can share code around database connectivity if we've got an on-device database. There's special stuff that we do for the REST communication. You wouldn't really connect from your iOS device directly to your server. I'm not sure of any DBA who would be particularly happy about opening up the ports to your database through your firewall, for example. So you wouldn't connect from your iOS device when you're out on the road back to your corporate database. You may want to connect to it internally within the firewall, but certainly you can do that using the stuff that we have in the box for Interbase. because we have both the server and the on-device database versions. So let's explore that a little bit further. And part of what we provide you with specific editions of RAD Studio and Delphie is an IB Lite developer license for deploying out IB Lite. So this actually allows you to deploy out IB Lite. IB Lite is free of charge, it's fully featured, but it has a few limitations which you can remove if you pay for the full to-go edition. So let's look at the database choices that we really have on iOS. And the most popular one is SQL Lite, because the drivers for that are installed and deployed with pretty much any mobile device out there, because it's a free database. It offers some lightweight storage on device. It's it's basically, if you think of a flat file on steroids, you've got SQL Lite. It is literally, you can open it up and you can read it in a notepad if you want to and see everything that's in there in clear text. It is very simple storage that's got a single read, single write mechanism, so you can't be doing multiple threads against it particularly safely. If you compare that to Interbase to Go, then it's fully featured, it's got secure encryption. IB Lite is the same as Interbase to Go, apart from the encryption's disabled and there's restrictions in terms of the disk size and the concurrency, but we'll talk about that in a moment. But Interbase to Go has full SQL 92 database support, so you can do multi-reads, multi-writes, you can use stored procedures and triggers and exception handling, unique keys, primary keys, all the stuff you'd expect to use in a full-scale database. You can embed in a few meg into your application. So the difference between the editions is on screen here now, and we'll make sure there's a link up in the resources so you can see this. If you go, in fact, if you go to Interbase, if you go to the Interbase page on the Embarcadero website, you'll be able to see all the differences here. Now, to connect to either SQL Lite or IB Lite or Interbase to Go on the device, then you can use FireDAC. So it's the same database components, and so you only need to learn the one framework. And in fact, when you move off iOS and move on to other devices, FireDAC has a whole host of different native drivers that it supports. Everything from Oracle, DB2, MySQL, Postgres, MySQL, Sybase, Access. It even has an ODBC driver, so you can connect through, and also has support for DB Express drivers, so you can have FireDAC as a bridge to old DB Express drivers if you want to use those. And some of the stuff FireDAC does behind the scenes is exceptionally fast, including the parameterized updates and things like that. So we won't have much time to look at some of the advanced features of that today, but let's have a quick look at some of the basic features that it provides through. So I'm going to use an Interbase Lite example here. So on my screen here we've got our physical database connection. Now the driver name has been set here to IB for Interbase, and if we double click on this, we can see here the values for where the file is on my local machine, my username and password for connecting into the database, what SQL dialect we're using. There's a number of things we can view here. We can even test a connection to it to make sure that it connects up and works okay. There's a script window. You can get information about the database in here as well, and a whole load of different formatting options that you can check through. Okay, so with the database, obviously we need to be able to query that. So we've got a table here and a couple of queries. The table literally is pointing to the task list table. Sorry, it's pointing to the task list database. And if we have a look down here at the table name, it's pointing to the table called task. And then we've got two queries here for an inserting and deleting. So if we In fact, if we just double click on this, we can see this says insert into task, the field task name and the value task name. So this semicolon here indicates a parameter that we can call by name to then set at runtime. And you could have multiple fields just separated by commas and multiple values separated by commas in there as well. This is just a simple example though. And then the delete is delete from task, where task name equals the value that we pass in as the parameter. So if we explore here, let's go under the add button. We can see here we're using the input query to open up a dialog that is going to ask for a value to be passed in. And the default value we're going to pass in is appointed to this variable here. So we could set this to have a default name if we wanted to, but we're just going to leave it blank. And we're checking then, after this executes, if the value trimmed off any spaces on either side is equal to nothing, then we're saying if it's not that, then carry on. And then we're taking the query insert, we're setting the parameter by its name. So remember that full colon indicated the parameter's name. We're setting the task name, we're then going to execute the statement, and we're then going to refresh our table so we can see the new data. And then we're just going to use the live bindings here to tell the binding list to refill itself. So this isn't kept in sync with the table here, so we're going to do a manual fill of the table so it updates the list. Likewise on the delete, we're just going to do something very similar where we get the task name from the selected item in the list view. We're then going to set the parameter, execute and refresh the list, and take it on from there. Okay, so we've also got, this is quite interesting, there's on the forms idle, so when it's not doing anything, it's checking to set the visible state of the delete button to be if the list view selected is not equal to nil. So if the list view has a selected item, the button will be visible, otherwise it won't be visible. And we've already seen if-defs. So here we're just using the if-defs to update the path only when we go and run. So if I wanted to test this on my local machine on a Win32 target, then it will just connect to my local database. Otherwise, when we deploy out to the live installation, then it's always going to run this and update to the local database file, which again is in the documents directory because we want to keep that file even if we clear the cache. Okay, so before we can deploy out an application with IB Lite, we need to go ahead and set up the deployment options. So under deployment here, we need to go to the features, which is this little two folders above each other, and we need to go and turn on the Interbase to go options. Now within here, we have to select, basically select everything, but just I would disconnect the Reg IB to go or Reg IB Lite option. You need one of those selected. So if you use the Reg IB Lite, it's going to use your IB Lite license. If you use the IB to go, then it will use an IB to go license. Now I just happen to have an IB to go license installed on my machine, so I'm going to use that for the demo, but typically you'd be using an IB Lite license here just by doing that. That's all you need to do, and apart from that, just make sure when you get your registration email through and you register your copy of IB Lite, that you put the file into the redistribution folder in the public documents on your computer. Okay, so once we've got that set up here, all we then need to do is just hit run. So I'm just going to go ahead and run this and deploy across onto my iOS device. And let's just go ahead and add. Here we can see the input query. Let's just do hello, and let's add in world. And I'm just going to go and close this application now. And if we relaunch it, we can see that we've got those two values there. If we select one of the items, we can then delete it, and we've then got everything deleted. So very, very easy to persist data with IB Lite. Now, obviously, using SQL Lite, you can do something very similar using the using the FIDAC drivers. So there's an example of that in the samples directory. So if you go through the samples directory we spoke about before, there's an example in there for you doing exactly the same thing using SQL Lite. Now, the only thing to be aware of with SQL Lite, obviously, it's not as full-featured. If you want to put some business logic into your database, then you can't do that in the same way that you could do with IB Lite. And also, the nice thing about having an Interbase database is that if you want to take it off your device, you can then access the same database on Windows, on Mac, on Linux, on Solaris, because it uses the same on-disk structure. So you truly can have a database in the corporate environment that you're updating a whole load of stock information and everything else with, that you can copy when on the local network for speed, straight onto the device, store it there, and have all the same business logic that you put into the database running on the iOS device, which is fantastic. Now, the only exception to that is external functions, but that's a pretty advanced feature of the database, because we can't have external libraries on iOS. That's part of Apple's rules. But if you want the full on-disk encryption, the multiple threads, multiple read-writes, and all that kind of stuff, IB Lite would be the way to go. So, Al, what do you think of Interbase then, mate?
Thanks, Stephen, for that great overview on Interbase IB Lite and FireDAC. It does look like Interbase Lite is an awesome embedded database for your iOS devices. So starting with Rad Studio XE4, a new Interbase edition has been rolled out. So the existing Interbase edition family of server, desktop, developer, and to-go has now been enhanced with an edition called IB Lite. So this IB Lite edition can be deployed for free with your applications. So IB Lite uses the same embedded deployment model that's similar to the Interbase to-go edition, with some limitations. So as Stephen showed during his lesson, this slide has the overview of the Interbase editions and their features and limitations. So to me, the most important Interbase Lite limitations are this 100 megabyte max database size, its one simultaneous transaction, and the ability to do database encryption. So if you need more space or more transactions and you need database encryption, then your other cost option for iOS devices is the Interbase to-go edition. But on mobile devices, 100 megabytes with one transaction is very likely to be sufficient enough. This ends this lesson number 4 on accessing local storage. The next lesson, lesson number 5, will cover building and accessing SOAP and JSON servers. For lesson number 5, we'll learn about SOAP and how to build SOAP servers. We'll also build clients to connect to the SOAP servers using WSDL documents and SOAP interfaces, and we'll also explore consuming JSON. So at this time, let's open up the call for any questions you might have.